Hello everyone. In the previous video, we have seen the concepts of ideal inverting amplifier circuit and also the ideal non-inverting amplifier circuit. And also we have seen how to derive the output expression of both the circuits and some of the model problems that are frequently asked in the previous examination. Now, in today's video, we are going to see how to find out the output voltage for the given op-amp circuit. So this is the given op-amp circuit. Okay, so here they have given that Vi as 1 volt. So two op-amp circuits are there and we have to find the value of output voltage V0 given the Vi as input voltage. If we clearly observe here, this input signal is given to the inverting terminal op-amp. Okay, so from this up to this picture we can say that it is one inverting amplifier circuit. Why we are calling it as an amplifier circuit? Here a closed loop configuration is used. That's why it is an amplifier circuit, and also the input signal is applied to the inverting terminal. Therefore we can call it as an inverting amplifier circuit. So this is the part 1. Okay, now the output voltage that is obtained from the first op-amp is applied as input to the second op-amp. So here if you observe, this second op-amp is also having a closed loop configuration, and here this output of one's first circuit is applied as input to the non-inverting terminal. So we can say that the second part is a non-inverting amplifier circuit. Okay, and here while solving the op-amp problems, always remember that we have to assume that the op-amp is working in ideal case. Now what do you mean by the ideal case? The ideal case is the node potentials at this point, that is the non-inverting terminal and inverting terminal are same, and the currents entering at the both terminals are 0. So this is the ideal op-amp condition, or we can say that the difference voltage between the two terminals are 0. Okay, now let us see how we are going to find out the output voltage. So this is the circuit they have given, and here they have given that the Vi as 1 volt. Okay, since the first part follows the inverting amplifier circuit, so I can say that the op-amp 1 follows an ideal inverting amplifier circuit, whereas op-amp 2 follows ideal non-inverting amplifier circuit. Okay, so the first op-amp, I can say that the output voltage V0 dash is having a basic formula, that is minus Rf by R1 into input voltage. Now what is the input voltage they have applied? That is minus Vi. So it is Rf value is 60 kilo ohm, so minus 60k by R1 is 1k into Vi as 1 volt. K gets cancelled, negative into negative is positive, so finally the first op-amp output voltage is 60 volts. Now the second op-amp output voltage V0 we can write as basic formula, that is 1 plus Rf by R1 into, now what is the input voltage that is applied at the second part? It is V0 dash. So now they have given the Rf as 9 kilo ohms and R1 as 1 kilo ohm, and the V0 value is 60 volts. So V0 dash value is 60 volts. Simply substitute that. Here k gets cancelled, 1 plus 9 is 10, 10 into 60 which is equal to 600 volts. So by remembering the basic formulas of ideal inverting and non-inverting amplifier circuit, we can easily solve for this type of problems. Okay, thanks for watching. If you really like my videos, please like, share and subscribe to my channel. Thank you.